Subdivision problem. The data represent actual prices of various garden homes in a new subdivision. The data have been rounded to the nearest 100 square feet and to the nearest $1,000. So let's say this is our X and this is our Y. So these are the tables of the data, okay? X is 1,900 up to 2,800, and the dollars is from 155,000 to 220,000. And look that they are also scattered because somewhere at the point, uh, notice here, going here, it is reduced, and from here to here, it is increased and then reduced, so they are scattered. Letter A, run a linear regression on the data. Record the correlation coefficients. Plot the regression equation and data on the same screen. And use a window of a range of 0 to 3,000. And let's do that. So this is the answer for letter A. And you could get this by running a linear regression on your grapher. Okay? So the given or the solved regression line is y hat equals 67.6358 continuous x plus 26,139.5007. And notice that the lines or the points, they converge on this region, but still the regression line is here. Okay, so this is what makes the S-stress approximately the minimum, and the line fits well because the points cluster near it. You can see the points clustering around it. Okay, so this is by methods of graphing. Letter B, based on the linear model, how much would you expect to pay for a 5,000 feet square house in this subdivision? How big is a house could you buy for $1 million? What do you call the process of calculating an X or Y value outside of the given data? Well, we have already have a clue on this, okay? What do you call the process of estimating an X or Y value within the given data? Let's do it one by one. Okay. So for letter B, our y hat is equal to, what is our y hat? Let's write our y hat, okay? Our y hat is equal to, according to the grapher, 67.6358 plus 26,139.5007, and our correlation coefficient is 0.9595. And we saw in the graph that they cluster around the line, which pretty much gives an impression that the regression line fits well. Okay? So for letter B, we could take y, or we could find y when our x is $5,000. So look here, $5,000 is, or 5,000 feet rather, okay, is not included in here. So we are going to use our regression line, and y hat of 5,000 is pretty much, when we use this equation, that will give us how many? If we solve it, that will give us 364,318.6490, or approximately, this is approximately $364,000, right? Wow. Okay. Well, it makes sense. 5,000 feet square is very big, right? Okay, so how big a house could you buy for $1 million? So what we're going to use here is, uh, do we have $1 million here? No, we don't have, right? So we're going to use the process of extrapolation. So we will do 1,000 or 1 million, okay, minus 26,140. That is the y-intercept. This is the y-intercept when x is equal to 0. Okay, we are extrapolating. Okay? Divided by 67.6358. Why did we do that? When y is 1 million, so this is our, okay, let us rephrase that, okay? So let us rephrase that. When y hat is equal to 1 million, that would give us 1 million dollars equals 67.6358 x plus 26,139.5007, or let's just call it like 140. Okay, we're actually finding for x, or the fit. Okay, so adjusting all of the given variables here and terms, we will have 1 million minus this 67 point, or not that one, okay? I overlook. Minus this, okay, 26,140 all over this 67.6358. So this will give us a value of x which is equal to 14,398.5887 feet, or this is also approximately 14,400 feet. Wow. So when you have a 14,400 feet square, then you can now that area of the house is equal to a $1 million value. Okay? So what do you call the process of calculating an x or y value outside the given data? So we call it extrapolation. We have said it a number of times, right? And we have encountered it a number of times. So when the number of data, okay, or when the x value is not on the list of the given data, so it's about extrapolation when you cannot find the data on the given. So the process is called extrapolation. Now when the data is on the given data, okay, the x value or the y value that we are about to get is within the given data, then we are going to use interpolation. Okay, so this is outside the data, and this is inside the given data. Okay, so now let's go to letter C. What real world meaning can you give to this slope and the y-intercept? So we are going to write again the given regression line linear function. So our regression linear function is y hat is equal to 67.6358 x plus 26,139.5007. Okay, what is our slope? 67.6358. And our y-intercept is 26,140. This means that this is slope means that this is the cost of your house per feet. So the cost of the house per feet is equal to $67.64 per feet. Okay? And the y-intercept is when x is equal to 0, meaning that a house could cost at the minimum, okay, when x equals 0, when you have only one house, a house could cost at least $26,140. Okay, this is the meaning of our x and y intercepts. Letter D, find x and y bar. These are the average point. Okay, average point. And show that the average point lies on the regression line. So our x bar, when we get the values, so let's take a look at our, this is our, what do you call this? It's our data. So when we take the mean of the x, this will give us summation of this divided by how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have n is equal to 9. Oh, I'm sorry. We have n is equal to 10. Okay? Over 10. So the summation of this divided by 10 will give us, it will give us 2,470 square feet. And our y, so our mean for y is equal to the summation of the y over 10 also. So this will give us 193,200 feet or dollars. Okay, so let's write it here. The first one is 2470 square feet, and this is the average for y is 193,200. Okay, now let's see if y hat contains the value of the mean for x. So let us see that. Y naught of 2470 will give us 67.6358 times the value for the mean of x, which is 2470, plus 26,139.5007. And this will give us the same value for our mean of y, which is $193,200. Therefore, our average point x bar, y bar, or the mean of the x and the mean of the y, is on the regression line. So we have answered letter D. So these are the answers for number 2, problem set number 2 for lesson 3-2. Okay, where is that problem set? Here. This is the answer for letters A to D. A to D. On the succeeding lectures, we're going to continue the computation, the solving for letter E, and then we go to one more problem, or perhaps two, and that's all for today. And I hope you enjoyed watching, and I hope you got clearer interpretation, or you understood very well the lessons about this linear regression, or using the regression line to compute for the best fit or the best fitting. Sometimes it's called best fit, sometimes it's called best fitting line. Okay, for the scattered data, for any scattered data. So once again, thank you for watching and have a nice day, everyone.